Okay, guys, so today we're going to go ahead and continue from yesterday's lesson. Yesterday we were solving cube root equations. Today, our main focus is only going to be inequalities. Okay, so that's what we're going to be solving today, inequalities. So this is going to be part 2 of yesterday's lesson. Okay, now we do have this do now question, which you guys should have already solved by now using the link in Teams. So I'm going to go ahead and continue with today's. So for today, we're going to be solving cube root inequalities. That means that all of the problems today are going to have this type of symbol, not like yesterday's problems where they all had equal signs. Okay, now the one thing to know when solving cube root inequalities, and notice that yes, do they have to be cube roots? Yes, they do have to be cube roots, meaning that you're going to have what we see right here, right? A root, the radicand, with the index on the outside. Okay? Now, when we're solving these problems here, okay, when solving cube root inequalities, okay, so they have to be cube root inequalities. The cube roots have an odd index, right? Well, what is the odd index? The odd index is this 3 right here on the outside, and that 3 is odd, right? We do not have to only consider when the radicand is non-negative. Okay, so it's not only when it's non-negative, like when we had to when there are square root inequalities. Now, basically what this means, it's going to be the way that we evaluate the answer at the end of the day, which you guys will see what I'm talking about right now. Okay, so here are the steps that I have for you. We have to solve for x. How? Well, we're going to go ahead and we are going to use SWBAT. Okay, so same thing as yesterday, use SWBAT. And if you divide by a negative, remember to change or flip the inequality. So that's just a rule to remember. And then represent your answer in inequality or interval notation, whichever one you choose. And now I'm going to go ahead and show you guys how to check your answers by graphing and what that looks like when we graph these, okay? And then just remember, what can you use? You guys can go ahead and use Desmos to check your graphing. Okay, now let's go straight into the first problem, okay? So this right here, we have to solve the given inequality. They're telling us here that it is an inequality. Okay, so we have to solve this. And if you look at this here, I have a cube root of x minus 3 greater than 4. Okay, so I'm just going to give you guys a little cheat here that if it's x is greater than, facing to the right side, then that's going to be greater than. Okay, and if it's facing in the other direction, that's when you guys are going to say that it is less than. Okay, so just keep that in mind. So since this one's facing to the right side, like we have it right here, I'm going to say that this right here is greater than. Okay, so this expression is going to be greater than. So that means that I want whatever values that I get, I want them to be greater than 4. Now, you guys are going to be like, what? We'll talk about that towards the end. That's going to be me showing you how to solve these problems with a graph. Okay, so how are we going to solve this? Well, like I told you guys in the steps, right, we're going to solve this using SWBAT. So I'm going to go ahead and I'm going to have SWBAT here. Okay, and of course, SWBAT means that I am going to start with subtraction. Okay, so do I have subtraction? Yes, but like we said the previous 2 days, is that it's inside the radical, so I cannot do anything with it. Addition, no. Division, no. Multiplication, no. Exponents / radicals, yes. Right? So how do I get rid of an index of 3? Well, we raise it to the power of 3. And what I do to one side, I do to the other. When I do that, this and this cancel out, meaning that I'm now going to have x minus 3 is greater than 4 to the power of 3 means 4 times 4 times 4. 4 times 4 is 16 times 4, it is 64. Okay, so I'm going to have x minus 3 is greater than 64. Okay, and now we can go ahead. Do we have parentheses? No. Subtraction? Yes. Is it inside parentheses or a radical? No. So can I go ahead and do something with it? Yes, I can. Well, what's the opposite of subtraction? Addition. So I'm going to go ahead and add this 3, add the 3. X is now going to be greater than 4 plus 3 is 7, so 67. Okay, so that right there is going to be my answer. Okay, well, I wanted to show you this on the graph, but the graph is like really, really big. So I'm just going to go ahead and create a quick sketch. So if I were to graph the cube root of x minus 3, right, that means that I'm going to go 3 units to the right. Okay. And that right there, that is going to be my rotational symmetry. So when I graph this, since it's a cube root, it goes down, meets the rotational symmetry. Once I meet the rotational symmetry, I rotate in the other direction, right? And so then that was the left side of the equation, right? And now I'm going to go ahead and do the right side. Well, you may be asking, what's the right side? The right side is y equals to 4. So that means that here I'll be 1, 2, 3, 4. Let me do that in a different color. Okay, now these 2 points right here, they intersect at 67, 4. But if you remember, right, this is going to continue up into infinity. Not only that, but I want it greater than what? Greater than 4. So what values am I going to want? I'm going to want all of the values above 4, because what values are greater than 4? Anything that's positive, bigger than 4, so 5, 6, 7, 8, 9, 10. So basically what I'm going to want to do is that I'm going to want values that are 67 or greater, so 67 all the way up to infinity, or you can say I want x values that are greater than 67. Okay, so if you were to do the graph, you can graph this and this, or you can graph you can graph this, but then instead of putting y equals to 4, you can go ahead and just switch that out and instead put y is greater than 4. And you'll see that it's going to shade everything above, just like I kind of did here, meaning that you want anything from 67 to infinity, or x is greater than 67, which these two literally just mean the same thing. Okay, so now I'm going to go ahead and give you guys maybe 2 more examples, or maybe 1 more, because this is literally pretty simple, and then you guys should be done for the day. Okay, example number 2, we are going to solve the given inequality. Okay, inequality, and we are going to get the cube root of x plus 5 is going to be less than 8. Okay, so that means if it's facing to the right side, it's going to be less than. Okay, so we're going to go ahead and how we're going to solve this using SWBAT. Okay, so do I have subtraction? No. Do I have addition? Yes, I do. How do you get rid of addition? By doing the opposite, which is subtraction. So I'm going to subtract that. Now I'm going to get the cube root of x is less than 8 minus 5 is 3. Do I have division? No. Multiplication? No. Exponent / radical? Yes. So I'm going to go ahead and raise this to the power of 3. The power of 3. These 2 cancel out. X is going to be less than 3 times 3 times 3, which means 3 times 3 is 9, times 3 is 27. So I want x values that are less than 27, and that right there should be my answer. Okay, so I can go ahead and say x values less than 27, or I can say I want from negative infinity all the way up to 27. Because if I'm going from 27, so it's kind of like you have a number line, right? I'm gonna be at 27, and I want all of the numbers that are less than, meaning that I'm gonna be going all the way to the left side. So I'm gonna go from negative infinity all the way up to 27, right? So if I were to graph this, I'm going to be going 5 units up because of this plus 5 right here. Okay. 1, 2, 3, 4, 5. And that means that's my rotational symmetry. So I'm going to go down and then work my way upwards the rotational symmetry. Then once I reach that, I go and I rotate in the other direction, right? And so then at this point, you would go wherever you have 8. So that would be 5, 6, 7, 8, right? And that would be your other, that one right there would be y is less than 8, right? Which means if it's less than, I want all the values going downwards. So I want anything from negative infinity all the way up to 27, because the point of intersection between this function and the actual cube root function is going to be somewhere over here, which would be 27, 8. If we were to graph this plus this right here, then you would see the graph that I'm giving you right here on the side. Okay, I'm going to go ahead and give you guys one more example. Example 3. We're going to solve the given inequality. Okay. You're going to get the cube root of x plus 2 plus 9 is greater than 12. And how we're going to solve this? Using SWBAT. Okay. Do I have subtraction? No. Yes. No, I don't. Do I have addition? Yes, I do. I have one inside and one on the outside. Obviously, the one on the inside of the radical, I cannot do anything. So I'm going to go ahead and I'm going to work with this 9. The opposite of addition is subtraction. Subtract the 9. So you're going to get the cube root of x plus 2 is greater than 12 minus 9 is going to be 3. Okay. Do I have division? No. Multiplication? No. Exponent / radicals? Yes. So I'm going to raise this to the power of 3. What I do to one side, I do to the other. X plus 2 is going to be greater than 3 times 3 times 3. Well, what's 3 times 3? 9. 9 times 3, 27. So x plus 2 is greater than 27. Parentheses, no. Subtraction, no. Addition, yes. Subtract the 2. So now we're going to have x values being greater than 25. So that's going to be my answer right there. Or I can say, since it's greater than, that I'm going to go from 25 all the way up to infinity. Both of these would work. So it's kind of like, once again, having a number line, right? We have the number 25. And what numbers are greater than? Well, the numbers that are going to be greater than are the numbers that are bigger than 25, which is 26, 27, 28. So you'll go from 25 all the way up to infinity. And that is how you solve cube root inequalities.